For step 3, we're actually going to look at this example first and work our way back because it's kind of conceptually a little more easy to see how to apply step 3 by looking at this problem. I'll show you why. What we're going to do is be evaluating these roots of our variables. In the overview, I showed you how this broke down into x times itself 12 times, and then we would find a fourth portion of it, and what is that? Or this is y times itself 8 times, and we would find a quarter portion of that, and what does that look like? But there's actually a very straightforward way to go about this, that we don't have to lay it all out there. When we're trying to find a root of a variable raised to an exponent, we're trying to find this portion of this number. So all we actually have to do is divide the exponent, the 12, by the root, the index of 4 here. That's going to be a quarter of our 12 x's. So for the step 3, all we're doing is taking the exponent that's here on our variable inside the root and dividing it by the index number here. So what is 12 divided by 4? That's a 3. So the 4th root of x to the 12 is x cubed. You're just dividing this number by that number. So what is 8 divided by 4? Just gives us 2. So our answer is y squared. Because what we're saying is this times itself 4 times gives us y to the 8. And that's how this happens. This is y times y, 2 y's. If you do that 4 times, you'll get 8 y's, all multiplied up together. So that means if we divide 8 by 4, we'll get 2, which is how many y's you would need to multiply by itself 4 times to get to the 8. So same thing here, 12 divided by 4 is 3. Notice how they're all the exponents. So how do we apply that to problem number 2 here? This one's straightforward. 6 divided by 3 is 2. So this is a y squared, is the cube root of y to the 6th. And this always happens. We can generally recognize that if we're taking a cube root of a perfect cube, we just get that variable. And the way it works here with our step 3 is 3 divided by 3 is 1. We don't need the exponent of 1, so 4xy squared. The reason why we work backwards is because there's no index here. We don't have a number to divide by. But you'll recall there's an implied 2. We're taking the square root. We want to know what times itself, just twice gives us this value. So you can imagine a 2 here, and we're just going to divide the 8 by this imaginary 2, and we'll get a 4. So the square root of x to the 8 is x to the 4th. So step 3 is just the last step. It's dividing the exponent of your variable by the index of your root, and putting that new number here as a variable exponent up top. Okay? So I want you to be able to see that we're evaluating roots. We broke this up into 2 pieces, evaluated this. The square root of 144 is 12. Those 2 things are the same. The square root of x to the 8 is x to the 4th. These 2 have the same value. If these 2 have the same value, and these 2 have the same value, then this is the same value as this. Same thing is true all the way across the board.